Hi, my name is Liz Magley, and I'm an applications engineer here at Keithley Instruments, a Tektronix company. Today we'll be making stable low current measurements on test circuits with high capacitance connections using the 4201 or 4211 SMU source measure units. The 4201 and 4211 SMUs are source measure units for the model 4200A SCS parameter analyzer. A source measure unit is an instrument that can source voltage and measure current, or source current and measure voltage. The 4201 is a medium power SMU and the 4211 is a high power SMU. The optional preamp can extend the SMU current measurement ranges down to the femtoamp level. These SMUs are optimized to make sensitive low current measurements, which is necessary for many device applications. The 4201 and 4211-SMU have increased maximum capacitance specifications. This is because test connection capacitance can cause SMUs to be unstable when making sensitive low current measurements. This is especially true when auto-ranging on lower current ranges. Factors that add circuit capacitance include long Triax cables, switch matrices, patch panels, chucks or probe stations, and even the device itself. This slide illustrates the maximum capacitance specifications of an SMU. Specifically, the Triax output terminals of the SMU are shown with an attached Triax cable. The three outputs of the SMU are force high, guard, and force low. The guard capacitance is the capacitance between force high and guard. The shield capacitance is the capacitance between guard and force low. The load capacitance is the capacitance between force high and force low. This table shows the maximum capacitance specifications for the 4201 and 4211 SMUs, which is much higher than traditional SMUs. The maximum load capacitance specification varies from 1 microfarad to 100 microfarads, depending on the current measurement range. Sources of system capacitance that add to the load capacitance include the device under test, coax cables, and the chuck. The maximum guard capacitance is 5 nanofarads and is usually due to Triax cables and connections. The maximum shield capacitance is 10 nanofarads and is also due to Triax cables and connections. To calculate the test capacitance from Triax cables, the length of the cables connected to force high and sense high to the device and the capacitance specifications of the cable must be known. In the example shown, a 4-wire remote sense connection is made from the output of the SMU to the device. 15 meters of cable is connected to both force high and sense high of the SMU, for a total cable length of 30 meters. The specifications for the cables that come with Keithley SMUs are shown. The total capacitance is therefore 2.9 nanofarads for the guard capacitance and 9.9 nanofarads for the shield capacitance as calculated. For a 2-wire or local sense connection, the cable length would only be 15 meters. Many applications require the use of high capacitance test connections. For example, the test system to measure an IV curve of an OLED pixel device on a flat panel display typically requires 12 to 16 meters of Triax cables to connect the switch matrix to the probe card as shown. In this example, the SMUs are connected to the glass panels to be tested using very long cables and a probe card. The SMUs test the TFTs and the OLED pixel circuits of the display by applying a gate voltage and measuring the drain current. This slide shows the IDVG curves of an OLED pixel device measured with both traditional SMUs and the 4211 SMU. The long Triax cables cause instabilities in the measurements taken on the left with the traditional SMU. However, the 4211 SMU made stable drain current measurements. Another example is a MOSFET that is measured by SMUs routed through a 707B switch matrix. Using a switch matrix adds extra cables to the system in order to connect the SMU to the rows of the matrix and then through the columns of the matrix to the device. In addition, remote sense requires cables to both force high and sense high terminals of the SMU, thus doubling the capacitance seen at the SMU outputs. In this example, 15 meters of Triax cables contribute to the test capacitance. This does not include any capacitance from the switch matrix, patch panel, probes, or chuck. The results of measuring the drain current versus drain voltage of a MOSFET through a switch matrix are shown in this slide. The IV curve on the left was measured with a traditional SMU and shows significant oscillations. Dramatic improvements are seen when using the 4201 SMU to measure the drain current through the switch.
Find out more at Vicom's website.